Assalamualaikum.
Waalaikumsalam. Betul.
Waalaikumsalam, Doktor.
Waalaikumsalam, Ustaz.
Grup mana ready?
Grup 12.
12. Dah ready? Okay. User ni siapa? User.
Saya Dr. Bismil Amin Shah. Saya tak tahu macam mana nak taruh nama.
Astaghfirullahalazim. Macam tulis nama kat WhatsApp.
Ha? Kat
Macam
WhatsApp.
tulis nama kat WhatsApp.
Sekejap.
Tak apalah. Nanti tak penting. Nanti kau belajar sendiri. Nombor 12. Nombor 12 pula. Grup 12.
Tak ada.
12 ada. Tak apalah.
Grup 12 apa?
Kami. Saya Bismil Amin Shah, Wan Afiq dengan Muhammad Rafiq.
Sekejap. Nak catat nama. Bismillah.
Bismil Amin Shah.
Bismil.
Ya, saya Doktor.
Bismil.
Amin Shah.
Bismil. Dengan nama. Dengan nama Amin.
Ya.
Lagi?
Muhammad Rafiq.
Oh, budak ni. Rafiq. Lagi? Lagi?
Seorang lagi jap. Terkeluar. Terkeluar tadi.
Keluar?
Assalamualaikum. Saya Wan Afiq.
Wan Afiq. Kau ada dua ke? Yang belakang-belakang jangan kacau. Yang belakang-belakang jangan kacau. Okay. Share slide.
Okay.
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 Bismillah.
Bismillahirrahmanirrahim. Assalamualaikum and good evening to everyone. Today, we from Group 12 will present for assignment 6.
Wan Afiq on video.
Okay. So, first of all, I want to introduce our... Okay, first of all, I want to introduce our group members, which is me, Bismil Amisha bin Yiribi, and my friend Muhammad Rafiq bin Ismail, and one Muhammad Afiq bin Wan Zaini.
Awak ni orang mana?
Saya ke Doktor? Orang Negeri Sembilan.
Oh, nama lain macam?
Parents orang Indonesia.
Oh, orang Indon.
Yeah.
Bapa Indon, mak Melayu.
Dua-dua Indonesia.
Oh, jadi engkau IC merah.
Saya dari sini, jadi IC biru lah.
Okay.
So now we look at question 1. The question is you want to consider an feedback system with the loop transfer function. So they give the transfer function and they want to ask us about how we want to reduce the overshoot becomes to 32%. So let's look at the flowchart first. So for the flowchart to solve this question 1, the first step is we have to create the M file at MATLAB lah. Then we have to do to insert the closed loop transfer function first. So if we look at the question is open loop. So we have to make it closed loop first. Then we insert in the MATLAB. Then we try to run and to determine the percentage overshoot. Is it 46%? Then if already 46%, then we have to adjust the value of 0 because we want to determine the value of 0 when the percentage overshoot become 32%. Okay. So we adjust the value of 0 until we got 32%. Then after we got 32%, that's it. So finish for the flowchart part. So this is the MATLAB code for question 1. Like I said before, we have to determine the closed loop transfer function first. Then we have to set the time. Then we have to do some coding to determine the percentage overshoot. So for this one, as we can see, the value of z is 1. So from the MATLAB code, we got the value of percentage overshoot is 47.1177. Almost the same for 46 because maybe have some other possibilities, some error, MATLAB error. So after we finish for uh, percentage overshoot 46, then we have to adjust the value of z. For this part, we have to do the try and error method. So we try adjust the value of z until we got the percentage overshoot become 32%. Okay, so as we can see from the slide, the z determined is 0.57. When we insert 0.5, sorry.
Batuk.
Oh, so when we insert the value 0.57 into the zeros, so we will get, okay, oh, sorry. The percentage overshoot become 31.9978, so equivalent to 32% lah. So from the coding, it can be seen that we already done for question 1. And so for the discussion for question 1, like I said before, for observation, it can be seen that the percentage overshoot in the MATLAB code is 47.12, which is have a small difference between the value in the question, right? So they have two possibilities. The first one is numerical precision, and the second one is algorithm approximation. So the MATLAB basically they already the number is like they will sum of the number, if they're too small, they will be round off. That is for the MATLAB. So maybe because of that, it will affect the result lah. So they will have a small difference between the question part and the coding part. And for the value of 0 also, uh, we think that this method is not very nice because we have to do the try and error method, right? We don't have any step with systematically. Then for the improvement and the suggestion, I think maybe we can try to use other software, or maybe the question is can give some other parameter, so we can do the manual calculation easily, and maybe we can use another software to plot the bond. Can determine the percentage overshoot, right? So this is for question 1 lah. Okay, now for question 2, I will move
Excel mana?
Excel. I already tried
Simulink.
Simulink. I'm sorry, doctor. Before this, I asked another group, and they already said that they already asked doctor. And
Apa yang cakap tu? Saya dah bagi dalam format PowerPoint, tak baca ke format PowerPoint tu? Kan ada tulis.
ada doktor. Ada, tapi before this, for the Excel part, I already tried to put it into Excel, but I cannot get the result.
Mana boleh macam tu? Grup lain dapat? Dia tak ada Excel, tak ada Simulink, markah rendah sikit lah.
How about maybe after this we can try to do it again, doctor?
Boleh
Is it
sampai
okay?
hari Sabtu untuk
Okay, doctor, can.
menambahbaikan. Dia dalam format tu dah cakap dah.
Ya.
Tak buka ke? Siapa ketua ni? Ketua siapa?
Buka. Kami buka, cuma itulah sebab tanya ada group, so most of other groups.
Jangan tanya grup. Tanya ketua dia. Siapa ketua dia?
Doktor ketua. Sorry, doktor.
Yang nak menanda tu. Bukan grup tu tak menanda. Okay, next.
Okay, so for question 2, I will pass to Rafiq. Rafiq.
So we move to question 2. So
Okay.
for the questions 2, the question asks to plot the frequency response. Next. Next. So this is the flow chart to solve the question 2. So we begin with start and create a code for MATLAB and run the MATLAB code. After we run the MATLAB code, we can see the frequency response plot. After that, we can do the manual calculation and compare between the manual calculation and the simulation part. If the both is similar, then
Kenapa echo Suara awak echo.
off mic.
Off mic. Mic off.
Sorry, sir. So if the both result is similar, we can end the question. But if not, we will check the manual correction again.
Okay.
Next. So for the MATLAB code is just a bit, just like in the slide for in our class. But we add the margin G so that we can already get the GM MPM at the title of the box plot. So we can see here that the GM.
Kenapa grid tu tak keluar dekat ni? Ada command grid tapi tak keluar dekat drawing ni.
Because we add the margin G. If we remove the margin G, the grid will appear.
Apa dia?
Because we add the code margin G, I don't know why, but the grid code didn't appear. But if we remove the margin G, the grid will appear.
Okay.
Okay. So we can see here that the GM is infinity and PM is negative 100 degree at 0 radian per second.
Berapa dekat ni? Berapa dekat?
Berapa dekat?
Drawing tu berapa dekat frekuensi?
Berapa? 6. 6 maybe. Berapa dekat?
Bismi, berapa dekat?
Yes, sir.
Allah, tak tahu juga. Hafid, berapa dekat frekuensi drawing ni?
5 dah tu.
20 kan?
Semua
45.
pandai, semua tak tahu. Tengok ni. 1,
45.
2,
5.
3, 4,
Oh, aku terkira dengan ini.
5. So,
Aku terkira dengan ini.
1, 2, 3, 4, 5. 5 dekat lah. Mana datang 6?
Sorry, Doktor.
Betul lah saya kan.
Apa? Itulah belajar tak melekat lah budak-budak. Okay, teruskan.
So we move to the manual calculation.
Okay.
So for the manual calculation, the parameter is given, so we just to plug in the parameter into the transfer function, and we will get that the break frequency at zeros is 100 and pulse at 1000.
Bukan plug in, insert.
Sorry sir, insert.
Plug in tu wire tu plug in.
Okay, sorry sir. So for the magnitude, we will get 0 dB. Next. This is the graph for magnitude dB and degree. Phase. Magnitude and phase.
Macam test lah itu.
Yes. So they have 20 dB per decade and 0 dB when we combine the graph. Also for the degree, we will get the shape for the manual calculation and the simulation is same. But we got the PM here is 180, but I don't know why in the MATLAB is negative 180 degree. because
Kosong,
we the system is marginal, right?
saya tak tahu drawing you ni betul ke?
I
Tengok yang
think
original drawing, yang computer drawing.
simulation ni
Tengok kat mana dia cross 0 dB tu.
0 dB at 0 degree.
Hmm.
So 0 minus negative 180 will be 180, right?
Garisan magnitude tu potong dekat 0 desibel dekat 0 10/0 kan. Ah, Okey lah, benda tu tak penting sangat. Ni
Okay,
dia compensator ni. Okey, teruskan.
okay. So for the discussion, we can see that the shape of the box plot between manual and simulation is same, but unfortunately for the value in manual calculation, we cannot get the exact value because we only sketch the box plot. So we can see that at 180, the frequency is at 0 radian, and the GM is infinity, and we don't know the frequency because it is too large. So for the suggestion, we can use appropriate drawing in the box plot graph, or we use the software that can generate the smooth graph so that we can have the manual calculation for the box plot is more similar to the simulation. So for this system, due to phase margin is never touch the negative 180, so the system is sufficient phase margin, and it is good to prevent oscillation, overshoot, and other stability issues.
Sama ni dia tak ada Excel, tak ada Simulink. Question
Yes, Doctor.
Proceed. Question 3.
Okay, now we move to question 3. So I will do for question 3.
Apa pasal kau pula? Afiq buat apa? Oh, okay.
Saya nombor 5, Doktor.
Okay.
So let's move to the question 3. So for the question 3, we have the function, right? We see that the function has time delay. So the question asks to determine the gain that maximize the phase margin. Okay. So for the first step, let's look at the flowchart first. Okay.
Time delay tu apa, Bismi?
Sorry,
Time delay tu apa?
time delay tu dia just a delay lah, Doctor. Maybe like let's say our function start from the 0 kan. Then if we have the time delay, the function will move to the right a little bit.
Boleh draw?
Sorry?
Boleh draw?
Boleh pakai pen ke, Doktor? Oh, macam mana Doktor draw?
Jangan tanya. Engkau tanya banyak. iMac semua boleh muat. Okay. So, time delay ni katalah output. Yang ini kita panggil dia sebagai Allah, hilang pula. Time delay. Nampak tak?
Nampak, Doktor.
Rafiq, kau nampak tak?
Nampak, sir.
Ini kita panggil time delay. Biasa dalam heater lah. Macam kita masak air, bukan tekan switch, bukan terus dapat air panas. Kan dia maintain masa kan, nak capai 100 Celsius suhu didih kan. Dia lambat, dia masa lengah. Biasanya heating system ada time delay. Teruskan.
Okay. So let's look at the flowchart again. So to solve the question 3, the first step is we have to define the function in the code and we have to define the range of k first, because at this question, like we can see at the question, they give the range of k 0.1 until 10. So after we define the range of k in the code, then we try to run the MATLAB. And after we run the MATLAB, we have to determine the bot plot, which is phase margin versus gain. So basically, when we do the bot plot in class is phase margin over frequency, right? So this time for question 3, we have to change a little bit. So the y-axis is phase margin and the x-axis is gain. No. The y-axis is gain and the x-axis is phase margin.
Balik.
Okay. So then after we settle for the plot, we have to determine lah the value of gain that maximize the phase margin. So settle for flow chart. Then we look at the coding. Okay. Then
Sekejap. Lean space tu apa?
linear space, actually we have to set it's like an array. Sorry. Array. We have to the coding is we have to set 0.1 until 10. We have 100 set of data.
Okay.
That's why we use linear space lah. So 0.1 until 10 we have 100 data lah.
And
So we
then
can plot the graph better.
base margin zeros size k. Apa maksud tu?
Yeah, the function is we want to create an empty vector because the value of phase margin we have to store first to the some place. Then after we store it, then we can transfer it to the plot lah. We can plot it. Okay, settle for this part. We look at the second code. So in this part, actually it is
off
like
mic, double mic,
sorry.
off mic. Bergema suara.
Siapa tu?
Bilik awak siapa yang on mic tu?
Apa tu? Maybe slowkan sikit volume. Try slowkan volume.
Okay.
Okay. So actually for this part it's like Mimo model for MATLAB because we have a very variety set of data. We have 100 set of data. So actually this one is multiple input and multiple output lah. So for the coding we have to code using for the loop lah. We have loop, and for this part we do the coding, and then after we do the coding we have to plot it lah. Okay. So settle for the code. And this is the result. As we can see from the result, the phase margin when the gain actually when they increase the gain is increasing. So the phase margin at first the phase margin will increase first, then until it reach the maximum value, then it will be decreased when the gain is increasing. When we discuss at class, basically we already learned that when the gain increase, phase margin decrease, right? So that is the theoretical part. But in this question, we can see that at first for the initial part, the when the gain is increased, the phase margin also increase, but just a little bit lah. Just a few times, maybe few seconds.
Apa maksud optimal gain?
Optimal gain which is the highest gain that the highest gain of the system that can get the phase margin is maximum. That one is the optimal gain lah. Okay, then for this part we get the maximum phase margin which is 67.2528 and the optimal gain is 2.4. Okay, so we got the result. And for the discussion, okay, so for observation, like I said before this lah, we can see at first the phase margin is increasing, then after reach the maximum value, it will decrease lah when the gain increasing. So our finding is we already know that the phase margin is a measure of system stability, right? So the larger the phase margin, the stable the system, the more stable the system. So we can say that to get a better stability, we have to increase the phase margin lah. But basically when we increase the phase margin for theoretically, the gain will be decreased. So when the gain decrease, the phase margin is increased. So but for question 3, we just have to set the time delay just less the value lah. Maybe we can set the time delay to become 0.1 instead of 0.2. So when we put the time delay to be 0.1, which is lesser than the first part, so we can get the result become higher. The phase margin, the next phase margin, the new phase margin will be higher, and we also get the gain for the maximum phase margin also become higher. The one is the maybe we can improve for this question lah to get a better stability. So I think that's all for question 3. So we can move to question 4. Okay.
So for the question 4, we need to verify the open loop transfer function that will produce the gain margin equal to infinity and the phase margin is equal to 9.8 degree. Next. Next. So this is the flow chart to solve the question 4. Same like in the question 2, we need to create a MATLAB and run the MATLAB code to display the bot plot. After we get the bot plot, we need to verify if the GM and the PN is the required in the question. So if there is if the result is similar, so we can proceed to other part. But if wrong, we need to change. We need to check back in the MATLAB code. Maybe we did a wrong code. So if the GM and PM is infinity and 9.8 degree, we will proceed to do a manual calculation and compare the both result. Is it similar or not? If similar, then we successfully answer this question. Next. So for the MATLAB code for question 4 also just a simple one. We also use the margin G, a code margin G, so that we can know immediately the PM and the GM for the question 4.
Pagar yang kat last tu pagar apa? Ada pagar lepas margin G tu.
Yang ni cursor je.
Ha?
Cursor.
Yelah, buat apa dia ada kat situ? Itu coding ke?
Ter screenshot sekali.
Check ke? Check lah.
Sorry sir.
Buang itu, delete.
Nanti buat yang baru. Next. So this is the bot plot for the question 4. We can see that the GM is infinity, where the graph for the phase meet the negative 180 at the frequency at larger, and PM is 9.8 degree at 12.8 radian per second.
Berapa zeta dia?
Zeta next. So this is the manual calculation. We get the zeta is sert 15 over 15. 1 over sert 15.
Simplify lah. Simplify.
What?
Simplify.
Oh, simplify, sorry.
Bagi jawapan tak lengkap. Tak simplify.
0.26.
Okay.
Okay. So we can see the bot plot for manual calculation. Next. This is the bot plot for manual calculation. A lot of line to represent the variety of the damping ratio, just like in the slide. So
Betulnya tak payah buat ni. Ambil yang daripada nota tu. Yang standard second order tu. Nampaklah comparison. Ini lukisan apa ni? Aku pun tak tahu. Ini lukisan tak tahu apa maksud lukisan ni. Dengan tajuknya tak ada. Ambil yang saya punya note tu. Paste kat sini. Nampak kan lah. Dia punya tu 0.2. Tunjukkan. Compare to the standard graph, the zeta is verified equal to 0.2 something. Betul tak?
Betul sir.
Ini buat apa nak lukis? Ini bagikan mak awak lah. Teruskan.
So we can get so for the manual calculation, if damping ratio is 0.26, the graph will meet negative 180 at the larger frequency, just like the simulation plot.
Okay.
So the manual calculation is similar to the simulation. So for the discussion for question 4,
Ini tak apa, saya dah baca. Saya dah baca.
okay.
Ini saya dah tengok. Okay. Apa lagi? Sama lah. Tak ada ni. Tak ada Excel dengan Simulink. Okay. Habis. Habis.
Question 5.
Oh, ada lagi.
Okay, for last doctor. For question 5, the question asks when t equal to 0.2, find the k such that the phase margin is greater or equal to 45 degree using the margin function. And for B, it asks for to obtain the plot of phase margin versus t for k, with k, the value of k is same as a, with t is greater than 0 and equal less than 0.3 seconds. Next slide. For the flowchart, first we define the time first equal to 0.2 seconds, and we determine the value of k when the phase margin is greater or equal to 45 degree. When we determine the value of k, we continue to plot the graph when k is still the same as we got in A, and then we define the plot with t greater than 0 and less than 0.3. Next to code. For code, we define the loop transfer function first. We also create the array of gain value k with range of from 11 to 15 with 100 data, and we define the desired phase margin set to 45 degree. We initialize the optimal gain and make phase margin equal to 0, and then for next slide. First we comparing the phase margin to desired phase margin with phase margin. PMI is less than or equal to the desired phase margin. So the last one, we just display the plot, the highest gain versus the minimum phase margin.
Ini looping. Dia punya loop. Looping berapa kali dia loop? Berapa kali dia looping?
Tengok.
Hello? Berapa kali dia looping?
Slide kiri-kiri. Oh.
Sehingga dia dapat maximum phase margin lah. Betul tak?
Oh, betul. Sebab kita orang try and error satu-satu nilai K tu.
Okay, terus. Apa
Terus untuk B. the end. For B, we set the new gain value. The optimal gain value is obtained from the previous section, and we assign it to k new variable.
Okay.
This will ensure that the new gain value is used for further result.
Okay.
And we compute the new transfer function, which is the PM new I equal to margin G new I, and we just plot the S and Y label time versus phase margin in degree.
Okay.
Next.
Phase margin.
And we got the graph like this. It is decreased linearly, the phase margin versus time. And we got the highest K for this
Apa questionnya?
13.02.
Question ni berapa? Equation dia. Persamaan dia berapa? Tak, graf tu. Graf ni panci tu. Apa persamaan dia?
Graf.
Afiq. Ya Rabbi, orang tanya si Afiq ni tak.
Yes.
Afiq.
Persamaan mana?
Afiq. Wan
A
Afiq.
dengan B ke?
Persamaan ni, persamaan
Saya tak dengar.
persamaan ni. Apa persamaan dia?
Y equal to negative
Tak.
mx plus c.
Saya tak tanya Rafiq, saya tanya Wan
Oh.
Afiq.
Lek budak.
Tadi aku dah tanya kau, Wan Afiq lah pula.
Lek budak.
Tak tahu. Tak tahu kena carilah. Equation dia linear tu kan? Betul tak? Bismi. Bismi.
Ya, doktor.
Y
Lek, doktor.
minus mx plus c kan? Dia dia negatif. Cari dia punya slope, cari dia punya intercept, masuk dalam. Ni y. Ni x. Y apa? Y apa?
140.
Bukan.
Y 140.
140 tu inilah dia. Dia punya variable dia, phase margin.
Phase margin.
Budak ni tak tahu ke apa? Ni metrik mana?
Apa?
Metrik mana ni? Apa tu metrik mana? Ni X sama dengan time kan?
X sama time.
X sama dengan phase margin. Janganlah tukar. Ya Allah. Ya tebi kan? Phase margin sama dengan minus M darab M plus C.
Plus C.
Wan Afiq. C
Ya. C Y intercept. Y intercept, doktor. Y intercept.
Cari. M apa?
M kita
M apa?
Y over X. Y
M kita tu lah ni.
lah. Gradient tak?
Tu. dy dx.
Kalau X lah.
Bukan y over x lah. dy dx.
466.67.
Ini senang je. Bukannya graf dia macam gini. Graf dia lurus saja. Kalau graf macam ini, munasabah lah tak boleh jawab.
Dia punya M 466.67.
Itu kendian lah. Nanti masuklah dalam penambahbaikan. Setelah ditegur oleh pensyarah kan. Dah. Ada lagi? Habis dah. Ngantuk dah ni.
Dah habis ada.
Okey. Buat pembentukan. Hari Sabtu hantar.
Okey.
Hantar .zip complete M file dengan komen Simulink Ismi Simulink dengan
Sorry, doktor.
M file attachment PowerPoint Simulink dengan Excel.
Okey, doktor.
Okey, doktor.
Okay.
Ada siapa kat belakang?
Belakang?
Ada orang
Ada
hai-hai.
orang lambai.
Tak ada.
Ada orang lambai.
Ah, tu
Tak ada, tak ada. Tak ada, orang belakang saya tak
Botak,
ada.
botak, botak.
orang putih.
Kau dah main isyak belum? Takut ada gangguan. Pergi check. Saya tengok tak ada.
Berasa.
Tak ada.
Ke teruk benda nama
Doktor pakai filter kot.
filter.
Kilometer.
Saya tengok tak ada. Kau rasa
Filter sir, doktor.
Doktor pakai filter.
tak ada lah, tak ada filter. Mana ada filter? Tak ada orang belakang saya. Okey, okey, keluar, keluar. Bagi
Oh,
grup.
ya.
Okay, doktor, thank you doktor.
Grup nombor 10 masuk. Elisa.
Sebelah tu.
Bismi, exit.
Hello?
Okey, masuk.
Hello? Hello?
Masuk, masuk. Bismi.
Boleh dengar tak
Wah,
kita?
orang nak share tak boleh. Okey. Elisa masuk. Grup nombor 10.
10 eh. Saya 11 doktor.
Sorry,
Saya keluar balik eh.
sorry. Grup 11. Grup 11.
11 ke 10 doktor?
11.
Okay.
Okey, start. Udah masuk belum?
Lagi 2 orang.
Apa dia?
Lagi 2 orang. Boleh dengar doktor?
Dengar. Lagi 2 orang. Okey.
Dan dengan Irsyad.
Sekejap, pergi toilet je.
Okay. Apa sebut?
Okay. Dah masuk.
Doktor, diorang kena Doktor Asad.
Ha?
Kena Doktor Asad.
Kenapa?
Tak tahu. Diorang tekan link tu pasal terus kalau apa ni tunggu host untuk approve.
Accept. Oh. Ya. Dia dah request belum?
Dah.
Tak ada pun.
Sekejap. Saya suruh diorang request lagi sekali.
Bagi link yang saya bagi pada awak tu.
Dah.
Tak, saya open je pakai password. Tak ada accept. Dia masukkan password, dia masuk lah.
Doktor.
Masuk. Dah masuk.
Dah doktor.
Okay. Start. Group lagi satu, relax dulu. Dengar aja. Idlan Haris mana?
Ilan tengah try doktor.
Tengah try.
Loading lagi.
Tak apalah. Jalan dulu. Jalan dulu.
And everyone, we are from group 11. We will present question number 5. So question part 1. Consider the aircraft unity feedback control system in figure CP 10.4 where delta T is the pitch rate radian per second and delta T is the elevator deflection radian. The four curve represent the Foucault and short period modes. The Foucault mode has a natural frequency of 0.1 radian per second and the short period mode is 1.4 radian per second. A, using box-plot methods, design a phase split compensator to meet the following specifications. Setting time with a 2% criterion to a unit step of TS less and or equal to 2 seconds and percent overshoot of PO less than or equals to 10%. B, simulate the closed loop system with a step input of 10% and show the time history of delta T. So the given figure, an aircraft pitch rate feedback control system has a lead compensator or GCS at temperature -10 over S plus 10 and aircraft -10 times by S plus 1 times S plus 0.01 divided by s squared plus 2s plus 2 times s squared plus 0.02s plus 0.0101. So to solve this question, first of all, we have to specify the desired characteristic and create block plot using MATLAB, and then display the block plot and obtain data needed from block plot to calculate beta and calculate the magnitude in the decibel. And then we can obtain frequency margin corresponding to the magnitude from the block plot and calculate T to obtain the lead compensator GCS. So here is our manual calculation. So from the question, given specification, percentage of overshoot equals to 10%, and then from graph, percentage of overshoot and damping ratio, we can get the value of damping ratio of 0.591, and from graph phase margin and damping ratio, we will get the value of phase margin 58.58 degree, which is equivalent to 60 degree. And from both plot, we will get the phase of negative 176 degree, and our phase margin is equals to 4 degree. And then the system requires phase margin at 60 degree. We use formula of the maximum phase angle to get the beta, which we rearrange and substitute the 60 degree. And finally, we get the beta is equal to 0.07. And we calculate the compensator's magnitude at frequency maximum, negative 20.3.78, which is, we will get negative 11.54 decibel. And from both plot, frequency margin corresponding to negative 11.54 decibel is 5.75 radian per second. And then we substitute the value into T equation as well as the beta. So we will get T is equal to 0.657. And lastly, we substitute the beta and T that we have obtained into the lead compensator standard equation. So we will get the final result. So here is the MATLAB source code. So for the first line, we create a transfer function variable, and second line define the numerator and denominator of the plant transfer function. Third line, we define the numerator and denominator of the plant transfer function of HS. Just now it's for GS, and then the next line is GA equals to G times H. We compute the transfer function. And lastly, plot the block magnitude and phase response of GAS. So here is the result. And from here, we from block plot.
Sekejap Kak, Simulink ni dia punya block diagram ni mana? Block diagram ni mana? Simulink ni.
Tak letak.
Tak letak?
Rasanya Simulink itu bukan buat diagram untuk Simulink, itu buat diagram untuk MATLAB code tu.
Ini rasanya
For Simulink in progress Prof.
in progress. Akak ni main tajuk, main letak je, dia tak semak ke apa. Ini bukan Simulink, Simulink mesti ada block diagram.
Tahu.
Okay. Betul kan tu tajuk? Tak salah.
Saya betulkan.
Not now, later. Tak not dia. Teruskan.
Boleh saya continue? Okay. And then from this, saya dah confused. And then we go to discussion part. For the observation, we can see that again, crossover frequency is 5.75 radian per second. And from our finding, with the workload, the lead compensator will increase the phase margin to reduce the percentage of overshoot and increase the grain crossover frequency and bandwidth to realize a faster transient response. And the suggestion that we can do is to increase the phase slip by placing a 0 before the minimum pulse of the system. By doing that, we can increase the phase slip. By doing that, we can improve the phase slip response in the desired frequency range and will improve the system performance. So increase the phase slip will help to push the system phase curve and increase the overall phase margin. So in conclusion, lead compensator is used to improve the performance and stability of the system, and the benefits of using lead compensator is we can improve system response, enhance the disturbance rejection, and stability preservation. That's all from me.
Ya, macam apa? Pemberita Astro Awani. Baca sepatah dia punya sepatah. Kita ni nak jadi engineer ke nak jadi jurnalis Astro Awani atau TV3? Aku pun tak faham. Irsyad, patutnya the next one after this presenter, the next presenter dia tengok, dia elaborate. Jangan baca. Kalau baca, itu adalah newscaster. Nak jadi engineer ke nak jadi newscaster? Teruskan.
Okay. Hello Doktor, boleh dengar ke?
Ya.
Okay.
Si lead compositor kan? Si Yolisa lead compositor, sekarang lead compositor. Teruskan.
Betul. Okay, for the question, part 2, the question have 3 different problem that must have be solved. First one is design lag capacitor by using a root locus method to design with specific to meet the design specification. Second, test the controller developed in part A by using simulating using MATLAB, and lastly compute the first margin using margin function in the MATLAB.
Okay, for
Dah tu kau orang pula.
okay. So next slide. First of all, my name is Idlan Harid Ahmad.
Tahu. Kenapa tukar orang?
Okay.
Jadi Irsyad tu apa? Dia tukar
Introduce myself je.
introduce yourself.
Okay, the flowchart for this question is, first we need to find the open loop and zero loop, pulse and zero from the transfer function given, and need to find the interception, angle, and lastly the breakpoint for the transfer function. First of all, we do the manual calculation and then we compare to using MATLAB. So we can determine the root locus before the lag compensator. And next, is it phase margin and J margin is satisfy the specification that given from question? If no, we go to the no, and then we specify the desired characteristic, which is we need to know the steady state error less than 10%. Second is phase margin need to more than 45 degree, and time sampling must be less than 5 seconds. And from that, we need to calculate the gain margin, the beta, and PC.
Beta tu apa?
Next, we obtain
Beta,
the lag compensator.
beta tu apa?
Tolong Syed.
The ratio between ZC and PC, which is ZC is higher break frequency and PC is lower break frequency.
Okay.
Okay, next, after we calculate manually to find K, beta, and BC, we have already lag compensator.
Laju sikit.
Next,
Biji cakap. Laju sikit. Laju.
next we create the MATLAB code after we put the lag compensator, and then display after we put the lag compensator specification to get the bob plot, road locus, and time response. And then we obtain the graph, and we can compare the manipulation and the MATLAB coding. Okay, next slide. Next slide. Sampai root locus punya calculation. Lagi. Okay, here. To find the open poles and zeros, Elisa, kat menu calculation for root locus before we put the lag compensator. Okay, thank you. First, we need to find the poles and zero from the function, and then we're using sorry. This is our sketching after we find the pole and zeros, and then we need to find the intersections of sigma A using this formula, and then we get 8. Next, we go to angle, interception, asymptote angle, using this formula that I write here on the slide, and then we get angle 180 and 360. And then for the breakpoint, we differentiate the transfer function, and then we get -20. So this is the sketching by using manually. Next, we using the MATLAB code. Next slide, Lisa. Okay. Bukan ni this is MATLAB source code before the lag compensator.
Jap.
And then the result for road locus
Jap.
before the slide. Lisa.
Sekejap, saya nak tanya. Ni apa? Series ni apa? Idelan, series tu apa?
Series tu
Tak tahu. Irsyad, series tu apa?
Series tu macam kita nak kaitkan dengan sistem G dengan sistem C. Sistem G tu before lag, sistem C tu after adding lag compensator.
You ke? Cascaded connection series tu.
Okay, cascaded connection.
SYCC ni SYCSG. Kan? Idelan, ni apa? Feedback.
feedback. After
Program bukan main canggih, tapi bila tanya tak boleh jawab.
Macam mana? Sorry Prof.
Kau dengar tak aku cakap ni? Speaker ada tak?
Ada, cuma takut mesh ataupun apa? Double dengan Irsyad.
Feedback tu apa? Feedback ni ya.
Feedback tu we convert the transformation open loop to closed loop transformation.
With unity feedback.
Yes.
Macam itu, unity feedback kan.
And then we set the range
Ni
for
apa?
the graph.
Tilda ni apa? Tilda tu apa?
Actually, after the real code is PM, which is phase margin that we get it, but I tried to run the MATLAB code. There is problem that we need to use that what? Apa benda column tu?
Dah. Okay, teruskan.
Okay. Elisa, for next slide.
Next slide. Okay.
Okay, here is the before the root locus using MATLAB. So is same with the manual calculation that the intersection for the x-axis is -20 and the pole and zeros.
Teruskan.
To satisfy the specification from question, we can see the detail the damping and overshoot, which is damping is 0.4 for sebagai bukti. Pergi dekat slide sebelum ni, Elisa, for damping ratio and overshoot. Yang awal, the previous one. Lagi satu, another one. Masih lupa.
Apalah, lambat. Okay, awak punya ni lambat. Okay, teruskan. Saya faham.
Okay, here. Sorry.
Saya faham tu. Saya faham.
First margin yang we desire is 45%, and then we drag the line to get zeta is 0.2, which is state at MATLAB. Summation. Okay, next slide.
Next.
From zeta 0.2, we get overshoot 23%. Okay, that's the proof from the MATLAB locus and the manual calculation. Okay, next I give it to Ishak.
Cepat sikit. Idlan ni slow present ni slow. Banyak time delay.
Okay, Elisa, can you show the manual calculation for after adding the lag compensator? Okay, this is the manual calculation for the after adding the lag compensator. The specification ZC must be greater than PC. So we start from steady state error which be given 0.1, and then we start the calculation by finding the KP by using the steady state has been given. So the KP we get is greater than 9. So we choose K compensator is equal to 0. And then we find the KP by using a limit by using the transfer function given, and we get 5. By using the ratio, we find the beta is 1.8. The value is acceptable because beta must be greater than 1 for the lag. And then from the root locus, the value of ZC must be from the first pole that near to origin. We assume ZC is equal to 0.5. We use formula beta is equal to ZC over PC, which is the ratio of the higher break frequency and the lower break frequency. And we get the beta is equal to 0.28. The value is acceptable because we get ZC is greater than PC, which is 0.5 greater than 0.28 for the lag compensator. And then we get the GC which is equal to 10 in bracket S plus 0.5 over S plus 0.28. From the MATLAB simulation, we got the phase margin is equal to 62.27 degree, and the settling time is 2.82 seconds, which is acceptable because the range for the question design lag compensator in this case must be greater than 5 from the workload intersection of y-axis, which is magnitude in dB. So we get 19.5 dB. So the KP that we get is 9.44. So the new steady state error we get is 9.58%. Next slide. Show the board plot after lag capacitor. Lagi. One more.
Dia tajuk salah ni, bukan simulink. Mana-mana korang ni buat simulink, buat peluk lah simulink dulu ke siapa mengajar ni.
Satu
Saya
lagi, Risa.
belajar pun simulink ni dalam dia mana-mana pula letak tajuk dia simulink. Betul-betul kan ni? Salah ni. Ajaran
Okay.
sesat ni. Menyebarkan ajaran sesat.
Ini terang betul kan?
Betul kan? Satu hantar balik yang dah fine tune nya. Okay, next. Saya faham ni. Saya faham. Teruskan.
Lagi, Risa.
Okay, yang ini okay, tak ada masalah. Okay. Cuma saya tak nampak Excel. Saya tak nampak Excel dalam awak punya ni dan saya tak nampak simulink. Jadi awak kena betulkan lah.
Baik, Doktor.
Masukkan dalam. Okay, itu saja.
Thank you, Doktor.
Itu saja.
Itu saja.
So betulkan. Kalau nak markah tinggi lah. Kalau tak, biasa-biasa je. Sebab tak ada simulink, tak ada Excel. Dilan, kau boleh? Yang biasa-biasa je boleh?
For Excel dengan simulink, we
Kalau
will
tak
do
nak,
after
tak
this.
apa. Kalau tak nak, tak apa. Tapi biasa-biasa je lah.
Nak biasa, nak yang luar biasa.
Okay. Kena buat pembetulan lah. Sabtu
Okay,
atau
baik.
Sabtu. Okay. Group
Keep
lain
off.
masuk. Yang lain boleh keluar.
Thank you, sir.
Alright. Okay, last group. Amir Syazwan, Atullah bin Nur, dan Adam.
Okay, Assalamualaikum.
On video.
Can start dah?
On video.
On video. Okay, Assalamualaikum and good night, Doctor. We are from Group 10. We present assignment question 4. Okay, the next slide is our question. First of all, I will start for question 1 first. Question 1, consider the control system in figure CP10.1, where GS equals 1 over S plus 12 and GCS equals 69 over S. Develop an M file to show that the phase margin is PM equals 60 degree and that the percent overshoot to a unit step input is 8.8%. Okay, for the manual calculation for question 1, we find the transfer function which is GCS equals 49 over S plus 12, and we factorize to get 1 over S in bracket S over 12 and plus 1. Okay, for the next, we put the bob plot, and at the 0 decibel, we drag the line to the phase graph, and then we will get the negative 120. It means that the phase margin is 60 degree. And the next is we verify the phase margin is 8.8% overshoot. Firstly, we at the 8.8% overshoot, we drag the line to the graph, and we will get the damping ratio. And at the damping ratio 0.6, we drag the line to the phase margin graph, and we will get the 60% overshoot. It means that at 8.8% overshoots equal to the phase margin 60 degree. Okay, for the flowchart, this is flowchart. We have 2 flowchart which is using MATLAB and manual calculation. For the MATLAB, first we make a MATLAB code, then we drag mouse till 0 decibel, we write down the omega PM. From the phase graph, drag mouse to the omega PM point, and then we calculate the phase margin, which is 180 minus value at omega PM.
Amir, ada looping tak?
Yes,
Amir? Ada looping tak?
looping.
Betul tak? Straightforward je. Ada loop tak? Decision ada?
I think looping if we don't have the 60-degree phase margin, we will need to do the gain adjustment.
Patutnya ada looping tu.
Yeah.
Ke kau tak nak buat looping?
I don't remember that.
Huh?
I don't remember.
You don't remember? Apa yang kau
I don't remember.
Apa yang kau remember? Adam, patut ada looping tak, Adam? Adam,
Yes, ada.
ada looping tak?
Not sure ada.
Not sure. Tengok soalan belakang depan dia. Soalan dia. Soalan. Lagi. Sekejap. Ni ada looping. Mesti ada looping. Nak dapat phase margin 60 darjah tu. Kan? Mesti ada. Pelik sikit lah. Dia straight je macam tu. Kamu check tu. Okay. Question tu. Dapat tak? Dapat? Dapat? Penyelesaian ni dapat?
Question tu first.
Tak
nak tengok code untuk question 1 dulu ke?
Boleh.
Okay.
Kamu sepa-sepa buat question 1 semua sekali. Question 2 semua sekali. Question 3 semua sekali. Jangan kamu program asing. Pening tengok. Sebab 3 orang kan.
Okay, this one is the MATLAB code for the question 1, which is at line 2 we define the transfer function. At line 5 we define the transfer function for GS. At line 8 we define transfer function for GCS.
Excel
And
mana?
at the
Excel.
Excel. Plot Excel this one for the.
Kenapa tak ada grid dekat tak ada grid ke? Dekat tu kena ada grid. Ini apa Ni log scale ke W ni? Ni patutnya dia log scale ni. Bang, ni log scale lah bang. Kau pakai graf kau ni macam salah. Log scale lah, log scale. Amir Syazwan.
Yes.
Log scale. 1, 10, 100K. Kau ni cerita apa Tidur ke dalam kelas? Salah ni. Check balik. Dia mesti ada gini. Apa? Dia punya grid vertical tu. Saya rasa graf awak salah. Betul kan balik? Okay. Question 2.
Question 2. For the question 2.
Question 2. Sama. Dia tanya apa? P controller. Ini gain adjustment. Kan? Okay, tengok dia punya program. Gain adjustment. Program and file. Patutnya question 1 tunjukkan dia punya M-file, tunjukkan dia punya Excel, kemudian tunjukkan dia punya Simulink, macam itu. Flowchart. Lepas tu question 2 tunjuk balik, repeat balik. Question 3 repeat balik macam itu. Okay, ni tak ada masalah. Tengok dia punya graph. True locus. True locus ke buat plot?
Buat plot.
Tadi ada
locus untuk question 3.
Ni sekali lagi. Macam pelik je graf kau ni. Saya rasa pelik graf awak ni. Ni. Saya tak tahu skill apa awak pakai ni. Dekat Excel tu dia ada skill log, tahu tak? Log. Adam, log tu apa? Adam ni baru bangun tidur ke apa?
Tak betul, tak betul.
Abdullah, log tu apa?
Uh,
10, log 10 frekuensi. Jadi bila tu awak buat, nanti dia akan jadi macam ni lah, 0.1. Kemudian dia ada 10 bahagian, satu dekad. Kemudian 1.0, 10, 100. Faham tak?
Faham betul.
Graf awak ni salah. Aduh, hai. Udah ni. Buat assignment last minute macam ni lah. Last minute ni. Lepas tu dia tak check betul-betul. Bandingkan dengan MATLAB awak sama ke? Tengok MATLAB awak. Question tu.
MATLAB
MATLAB
version
question tu. Mana?
ada pula tak tahu.
Tu.
Ini betul.
Ni.
Ni
Mana sama? Tak sama pun. Kan? Nampak? Nampak ni? Ni. Nampak tak? Ni. Scaling ni. Nampak?
nampak betul.
Kau ni scaling tu entah apa-apa. Ni berapa dekad ni Adam? Buat plot ni. Berapa dekad?
4 betul. 4 dekad.
Macam mana awak kira? Satu.
Satu kotak tu 1 dekad.
Bukan satu kotak. Satu bahagian ni.
Satu bahagian.
Satu dekad. Ni dekad kedua. Dekad ketiga. Dekad keempat. Itulah, awak faham tak? Dekad-dekad ni.
faham betul? Faham.
Berapa starting frekuensi sini?
Kalau buat plot ni dia 0.1. Sepatutnya kalau kat kertas buat plot tu 0.01.
Kat kertas?
Dekat kertas buat plot.
Jadi awak tambah lagi satu dekad lagi. Tambah lagi satu dekad, jadi 5 dekad. Ya Allah. Betul kan? Panas. Suhu panas lah. Aircon je. Okey, question tu sudah. Question 3. Siapa pasal question 3? Tengok 2 dah sudah kan, Amir? Amir?
Apa?
2,
Ya.
soalan 2. Gain adjustment.
Dua dah.
Soalan 2 gain adjustment. Soalan 1. Soalan 1
dari phase margin.
tu biasa je face margin. Nombor 2 gain adjustment. Nombor 3
Design controller compensator.
compensator apa? Lag ke leak?
Lag compensator.
Lag compensator. Silakan. Siapa?
Saya.
Silakan.
For question 3, we given GS 1 over S plus 2. We need to design compensator so that the steady state error to arrange input is 0. And the setting time is TS below than 5 seconds. And we have to obtain the closed loop system to the input RS 1 over S square and verify the settling time required has been satisfied and steady state error is 0. Manual. So for steady state to become 0, we calculate KV equal to infinity. And for settling time, we choose settling time 4 seconds, which is less than 5 seconds. From TS, we get the real, and from here, we get dominant pulse, which is -1 plus IJI. And for the GC transfer function, we choose KC S plus 0.1 and S plus KC S plus 0.1 over S plus 0.01. And for the transfer function of compensated system, KC S plus 0.1 over S plus 0.1 times S times S plus 2. Next.
Okay.
And to obtain the K, we use this equation. And S we substitute with dominant pools. For this question, K equal to KC. So KC for this question is 2.09.
How you get 2.09? Oh, daripada situ. Okay.
And apa soalan ni?
Next.
Uh,
Okay.
yang
Okay. Ini uncompensated kan? Okay. Ni graf semua salah. Excel semua salah. Buat balik.
tunjuk graf, tunjuk graf.
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 Salah tu. Graf tu salah. Betulkan balik. Question 3. Okay. Kenapa nak tunjuk rule locus Adam, kenapa tunjuk rule locus soalan nombor 3? Dia kan lag compensator. Adam ni blur lah. Soalan nombor 3 mana ada rule locus? Cuba tengok soalan nombor 3. Yang kau pergi tunjuk rule locus ni kenapa? Mana? Ada rule locus?
Tak ada.
Daripada mana datang rule locus tu? Gantuk lah. Adam, daripada mana datang rule locus tu?
Locus tu sebenarnya untuk PI controller.
Tak ada. Dalam ni dia tak cakap apa pun. Dia sekarang ni frekuensi respon ke time respon soalan ni? Soalan nombor 3 ni time respon ke frekuensi respon? Itulah.
Ya, Prof.
Soalan ini frekuensi respon ke time respon?
I think because of compensator, the question is frequency response.
Frekuensi respon. Tapi Adam tunjuk time respon. Kenapa?
Actually, we want to compare the. We think this question also can be solved using the PI controller method. So we want to compare.
Boleh buat dua-dua. Okey, tengok dia punya time respon.
But we don't make it in time.
Itu yang silap ni. Buat kalau nak compare buat dua-dua. Kan? Buat dua-dua. Betul kan balik lah. Kamu ni banyak gambar, tak ada discussion. Pening saya nak memahamkan. Cubalah tulis sikit komen tu. Betul-betul buat komen tu. Kemudian buat comparison. Adakah dia punya sasaran itu dipenuhi ataupun tidak. Okey, ada lagi. So tak ada Excel. Saya tak nampak Excel. Excel salah. Kemudian tak ada Simulink. Simulink pun tak ada. So kena tunjukkan lah. Banyak sangat gambar tak ada di sini. Setiap gambar tu yang figure tu tak ada penerangan. Ni discussion ni overall lah kan. Okey, ada apa nak tanya? Hari dan malam.
Ada.
Amir Syazwan. Awak nak betulkan ke atau awak nak terus hantar?
Betulkan.
Kita akan betulkan nanti.
Nak hantar terus pun boleh.
Tidak apa, kita orang nak betulkan.
Betulkan balik. Graf awak tu salah. Log scale. Okey. Good night, bros. Tak ada apa lagi Okey, terima kasih.
Thank you, Dr.
Terima kasih.